whenever we have arithmetic sequence in series, okay? So yesterday we kind of talked about where you have a sequence where it continues on, and it will either usually, yesterday whenever we talked about kind of introducing it, it was either adding or adding, subtracting is really the same thing. It's just adding by a negative number. Whereas whenever you have geometric, whenever we get into it, it's multiplying. Multiplying or what looks like dividing. Remember, dividing is just multiplying by a fraction. So with arithmetic, arithmetic is either adding or subtracting. Okay? It's really adding, or that's how we're going to look at it, but it may add by a negative number. So to tell whether something is arithmetic or not is basically from one to the next is the same value. It's going to essentially have a slope of a line. Okay? Because whenever we have slope, it's just the rate of change. So how much is it going up by how much as far as going over or basically moving left or right. So from negative 9 to negative 2, it goes up 7. From negative 2 to positive 5, it goes up 7. From 5 to 12, it goes up 7. Okay? From 12 to 19, it goes up 7. Yesterday, what you would have had to do was basically say, what's the next 2, 3 values in my sequence? And I would say 26, and then 33, and then 40, and go from there. So it will be arithmetic if that difference, or if the jump from one to the next is the same value. Okay? Whereas the one on the right is not going to be arithmetic because it goes negative 8, negative 6, negative 4, negative 2. It's going down by a different number every single time. So like in this case, is the first one arithmetic? Yes, no, maybe. Yes. What are we counting? We're going up. Okay. It's going up by 3 every time, right? What about on the second one? Yes. Because it's going down by 6, right? Or like negative 6. Or this one was a positive 3. Okay? It can still decrease. Okay? 15 to 9 is 6. 9 to 3 is 6 again. 3 to negative 3 is 6. Negative 3 to negative 9 is 6 again. Okay? We're just decreasing instead of increasing. What about the third one? Is that one arithmetic? Are we adding or subtracting by a constant number the entire time? No. What are we actually doing here? We're dividing by 2 or multiplying by a half, right? That'll come with geometric whenever we talk about that on Monday. So that one's not going to be arithmetic. So whenever we have an arithmetic sequence, okay, whenever we write the rule, so the one thing that basically I told you that you didn't have to worry about doing yesterday was you didn't have to write the rule. Okay? Because what would have happened, normally you would have been okay here, but then we would have spent a lot of time trying to fix mistakes or things like that. So we didn't even worry about having you write a rule because we were going to talk about it today. Okay? So whenever you write a rule for arithmetic sequence, again, it is going to look like a linear function. Okay, it's going to have a slope. It's going to have a y-intercept. Arithmetic sequence is really just the fancy way of saying, hey, you've got a straight line here. You have a number that has a slope, that has a constant rate of change, that starts at a certain value. Okay, we'll find that certain value. Now, usually the way that I will write this, if it's a sub 1, so the first term in the sequence, okay, is a sub 1, A sub n is your rule, or whenever we get further into it, we'll talk about it being your explicit rule. Whenever we talk about recursive rules, okay, and you don't know what a recursive rule means yet, you'll figure that out come next week. But this is what's called an explicit rule. It is specific to where I can find basically any number in my sequence just by plugging in. I can say, once I figure out my rule, I can say, what's the 25th term in the sequence? Okay? You plug in 25 to the rule, and you find that value. Whereas n is the term number, so it's that spot in line, essentially. And then D is the common difference. That's what we're counting up or down by. Now, normally I will write this where I will put the common difference. I will write everything normally, and it really doesn't matter, but I usually put it here, and I go D times n minus 1. Because what happens is students are used to distributing from the front and not the back. Okay, and that's what we will essentially do. So in this case, it says identify each of the aforementioned variables for this example. So what's the first term? What's the first term in my list? 3. How many values do I have? 7 of them. What is the common difference? What are we counting up or down by? 4. Okay, so it would be a 4. Okay, if you don't know as far as the common difference, basically what is it from one thing to the next? We're going from 11 to 5, or 15, is 4. 15 to 9 is 4. 19 to 23 is 4. 23 to 27 is also 4. Okay. So then, whenever we actually write the rule, okay, what I'm going to do, so to write the rule for the nth term. In some cases, there are basically 3 different ways that you can do this, or you can solve this 3 different ways depending on the information that you're given. The first one is obviously, or should be obvious, that it's going to be the easiest way of all, because it's going to give you a list and it's going to go from there. So if you're given the list of values, what you want to do is first, basically, if we have our formula of A sub n equal to A sub 1 plus D times n minus 1. Okay? We don't know what n is, but we do know, or we should be able to find, what's the first term, what is my common difference, what are we counting up or down by. So, in this case, what's my first term? 3. What is my common difference? What are we going? We're going up, right? So it's going to be positive. What are we going up by? 5. So then all I'm going to do, since those are the 2 main things that I have to have. Okay, I have to have the common difference. I have to have the first term. Okay, before I can write the rule, those are the 2 things that I have to have. So then, whenever I write the rule, I just have A sub n equals 3 plus 5 times n minus 1. I'm going to distribute the 5 to everything inside, and I'm going to have 3 plus 5n minus 5, combine like terms. So my rule is A sub n equal to 5n minus 2. Do the same thing for 2. Okay? Do you notice what's common? Where did that number come from? Where's the 5 also at? Huh? Yeah. Okay. Whatever your difference is, it needs to be the same number that's in front of the n. Okay? If we would, and usually it's easier for students to see, it's like, if I go back one spot, what's the number that would actually be in front of the 3? Like if I would go back 5 from there. -2. Okay, that's basically like spot 0. That's where it is on, if I would graph my line, that's my y-intercept. That's my starting spot before I count up or go over 1 and, in this case, up 5. Do the same thing then for 2. What's my first term? What's my common difference? 55. What's my common difference? -8. Okay, because since it went down, it's going to be negative. Okay, so since it's negative, that's fine. So then I just plug everything straight in. I have a sub n equal to 55 minus, I'm going to go -8 times n minus 1. Distribute the -8 to everything inside, so I have 55 minus 8n plus 8. Combine like terms, so -8n plus 63. That's my rule. Again, the common difference is the number in front of n. Okay, an easy way to check, since I'm going, normally I'm counting down by -8. If I would go right before, like what the number that would be in front of the 55, instead of it being a negative, I would add 8. So, what's 55 plus 8? It's the 63 that we've already done. Okay. Now, anytime it asks for a certain value, so it says find a sub 15 for both sequences. So all I'm going to do is take that 15. So like a sub 15 is just 5 times 15 minus 2. 5 times 15 is 75. 75 minus 2 is 73. If I would do the same thing then for the second example, I would go a sub 15. I just replace the n with 15, and I just plug it into my equation. So plug everything in and get -57. Now, in your second example, or your second case, okay, so case 1 is you're given the list, you know what the first term is, you know what the common difference is. Second case, you have some of the information that you need to know, but you don't have all of it. Okay. Again, we're still going to use the formula of a sub n equal to a sub 1 plus d times n minus 1. Do I know what my first term is? Right now. With the information that's given to me, do I know what the first term is? No. Do I know what the common difference is? Yeah, what is that? -3. Okay, that's good. I still need to know what my first term is. What do I know, though? I do know, right, a sub 19 is -45. So that means the 19th term in my sequence is a -45. Now, I could start at the 19th term and work my way back and keep adding 3 until I get to the first term. Do you want to do that? Do you want to go back 18 times and add 3 each time? I hope not. Okay, that's going to be a lot of extra work that you don't need to do. But I do have the formula. Okay, I have the formula where I can solve for the first term. So what I'm going to do is I'm going to take the value that I have right here, and I'm going to replace it with a sub n. So I'm going to have negative 45 equals, I do not know what a sub 1 is. We'll figure that out. I do know what d is, so it's negative 3. What number is going to go right here for my n minus 1? 19. So I have negative 45 equal to a sub 1 minus 3 times 18. So negative 45 equals a sub 1, 3 times 18 is 54. So minus 54. How do I get a sub 1 by itself? Add 54 over to the other side, right? So I add 54 to the other side. So my first term is 1. Or excuse me, my first term is 9. My fault. I saw the 1. And now I go right back to where I did before. I go with my rule. So go back to the original. Write a sub n equals, now what number am I going to put in for a sub 1? 9 minus 3 times n minus 1. Distribute. A sub n is equal to 9 minus 3n plus 3. So a sub n is equal to negative 3n plus 12. There is my rule. So here in case 3, okay, we had case 1 where we were basically given everything we needed. We were given our first term, we were given the common difference, and we could go. Second case, we were given the first term, or excuse me, we're given the common difference. We had to find the first term and then go with my rule. Whereas here, I'm not given anything. I am given something, but I'm not given anything that is relative to what I need. So before, first thing I was given everything. The second case I was given the difference and I needed to find the first term. Here I'm given just 2 random spots in my list. So I go from having everything to essentially having nothing. I don't know what my first term is. I don't know what my common difference is. So if I don't know any of those 2 things to start, I need to find first my common difference. All these values are, it's like finding slope whenever you were in your Algebra 1 class. Okay? Whenever you found slope, or even at the beginning of the year whenever we kind of rehashed that out and talked about it, okay? To find the common difference, I'm going to take my two big numbers. I'm going to subtract those. So I'm going to go 93 minus 17 divided by my two little numbers, 26 minus 7. You're used to seeing this as y2 minus y1 over x2 minus x1. It's the same thing. Again, arithmetic sequence is just finding the slope. Okay? Or it's a linear equation. So 93 minus 17, I'm going to have 76. 26 minus 7, 19. So I have 76 divided by 19 for a common difference of 4. So now I have a common difference of 4. Now I do it just like, now case 3 just turned into case 2. Okay? We're going to get the first term, and then we're going to turn case 3 into case 1, essentially. So then if I use my formula, does it matter which number I pick? No. What I would tell you, or what I would suggest, and again, it's completely up to you, I would pick the one with the smaller numbers, maybe the ones without the negative numbers, okay, depending on what you have, but I would use the numbers that are definitely smaller. Okay? You can use 93 and 26, that's fine. You're going to get the same answer as long as you do the math right. But I'm going to use numbers that are a little smaller, a little bit easier to work with, and I'm going to have 17 equals a sub 1 plus 4 times 7 minus 1. And I'm going to have 17 equals a sub 1 plus, I'm going to kind of do a little bit of math here, kind of 2 for 1. And then I'm going to take 17 minus 24, and I'm going to get negative 7. So now I have a sub 1 is negative 7. Now it just goes back to what I did before. And now it's just like case 1 where I have a sub n equals negative 7 plus 4 times n minus 1. Negative 7 plus 4n minus 4. And then 4n minus 11. There is my rule. Okay? If you don't have any of the information, case 3 is going to turn into case 2. Case 2 is going to turn into case 1. Okay? You're just working all the way through.